Hello, my name is Mahieyin Rahmun, and in this video I'll be demonstrating a simple CSV file parser implemented using 3 different languages. This is an assignment in the course CSE425, or Concepts of Programming Language. The constraint that was imposed on us in this assignment is that we could choose any 2 of the 3 languages, that is, the 2 languages could be our own preference, but the 3rd language must be shell script. We chose C++ and Python for our implementation. In this video, I'll be going over all of those implementations one by one. So without further ado, let's get started. So first up, I'll be opening up my terminal and navigate to my assignment directory. Open it up using my preferred code editor of choice, which is Visual Studio Code. And we can see all 3 of the implementations: the Python implementation, the shell script implementation, and C++ implementation. Before going over any of the implementations, I'd like to view the CSV file to get an idea of what we are actually dealing with. This is a CSV file containing over 10,000 lines and has 6 columns. So the way we designed our parser is that the user could specify the column he or she wants to search in and then give it a value. So our CSV file parser will match the column with the given argument and then print out the row if it matches with the user specified value. So if I open up the terminal and type, let's say for our shell script, if I type main.sh and then provide it with the CSV file's path, and then I could simply say -y, which is a flag for the year, to be, let's say, 2015 or 14. I could specify the number of deaths, which would be searched based on greater or equal to this specified value. So if I type 50,000, it will display me records with deaths greater or equal to 50,000 in the year 2014. So if I give it a shot, as you can see, it displays all of the records in the CSV file that matches our criteria. So if I want to display the help for this shell script, I would simply say /main.sh and then pass in the help flag, or I could even say h. As you can see, it will just print out a list of all the parameters that can be passed to this file. By the way, this is showing an error because I have chosen for the first argument here to be the name of the file. Since this is not the file, it is throwing me an error, but that's a minor issue. So let's look at the code. First up, I have set up the arguments. I want this shell script to parse. Here you can see the year, cause, name of state, number of deaths, and the age-adjusted death rate. Here is where the help flag is dealt with, and any unknown option is simply not cared about at all. This line over here tells the compiler to preserve new line characters. If this line is not present, if I type in this, the new line characters after each of those lines would be lost, and we will just see a jumbled up ball of text. To preserve those new line characters, we need this line. And this is just a long block of comment that I wrote down to help me remember what I am exactly doing in this AWK command. AWK is a string processing tool. So here what I have basically done is to set up the internal variables of AWK to correspond to the variables or arguments passed in by the user himself or herself. In this way, I will no longer need to reference to those variables that are being stored here inside AWK. I can simply just say year inside AWK and it will be parsed just the same. So in AWK, since grep doesn't allow numerical data comparisons, we have filtered out all the numerical data based on the user specified arguments. So if the user specifies year, deaths, or number age adjusted death rates, those results will first be filtered out recursively one by one, and at the end we just run a grep of the string values present in the arguments, if any. This is pretty interesting because even if the variables cause and state were to contain empty strings, it would not affect the script because it will just grep with empty string, and if it greps with empty string, it will just return the original string or piece of data. It can be mentioned that I am storing the AWK results in a variable called result and then calling grep on that result variable. So if I maximize the terminal, clear it out, and let's specify some more arguments. Let's say I want to find out the state, let's say Virginia. So show me records from 2014 in the state Virginia where the number of dates is greater or equal to 50,000. That's what it would say in normal SQL language if I were to query a database in the SQL. And it only found one record with our matching criteria. As you can see, the number of deaths is 63,598. So anyone with basic terminal knowledge would be able to run this. Next up, we will be looking at the Python implementation. Writing Python code for parsing a CSV file was very easy compared to C++ or Bash because it contains internal CSV module for parsing CSV files. This should be the natural way to go if you are parsing CSV files. I have a set of helper functions that helps me search the CSV file, and this is the main part of the program where I first set up the arguments that I want to pass to my script. Then I parse those arguments and form a dictionary of arguments which can contain both arguments and values as a key value pair, or it will be none for arguments that were not supplied to. Then I traverse through the dictionary of arguments and then keep searching the records recursively. For the first search, it is always the file because we have not yet attempted any search. For this reason, when it is the first search, this variable that contains the result will be none. Based on that, we will first search the file with the first argument that is not none, meaning that was supplied by the user in the first position. So if I go back to Python, and if my user says this main.py and then pass in the path to the file, okay, that's one directory above. It says no parameters were passed because I did not pass any parameters. If I were to type H, it will show me the help menu. Here you can see all of the parameters that I can pass to this script, and it will parse those arguments and then show me the results. Let's clear out the terminal. Whoops. Let's clear out the terminal, and if I say year should be equal to 2015, it will give me all the records pertaining to the year 2015. Now it's not very efficient because that's a long list of results, so I can further filter out the results by saying, let's say, only in United States, and then the cause should be self-harm or suicide, if you will. So I can find only one record from 2015 in the United States where the cause of death was self-harm. I can show another example where cause of death is self-harm and the number of deaths should be greater or equal to 60,000. It says no results to display for the given query because there were no such records. If I were to say 6,000, that's only one record. And if I were to remove this altogether, it will give me a long list of records. As you can see, United States appears in only one of those records. If I were to say deaths is equal to greater or equal to 6,000, okay, that's still too little. Let's try 3,000. Okay, so now we get a more plethora of records. So our CSV file parser works perfectly fine. So this is our C++ implementation, and this was the second most difficult one to write because C++, as you know, is quite an old language and it does not have support for most of the modern technologies that other languages offer. So you are stuck with basically reinventing the wheel, if I might say. So first of all, to clarify, I'm using the Boost library available for C++, which gives you access to some of these modern facilities that languages like Python offer. If you look at the code for setting up the argument parser, it's quite simple. I just specified the flags I want to use, and then I just parse those arguments using the built-in parseArgs function that gives me back a list, and I then turn it into a dictionary of arguments and then just iterate over the dictionary and filter out my results. That's not the case with C++ because, as I mentioned, C++ is a very old language. So first of all, I imported the Boost library, and then I set up the argument parser. If you notice what I'm about to show you in a second, you will notice some differences between the arguments passed in Python or Shell and the arguments passed in C++. Then I put these arguments, after getting them from the user, to a map, which is basically a Python dictionary. And then, if the user asked for help, I just display the help text, which I can show you right now. If I cd to C++, and CSV parser here is the compiled binary of this main.cpp. If I say help, as you can see, I have to pass in 2 flags as opposed to 1. It's the same even if I say this. If I say 1 hyphen, this is an internal issue of the Boost library which does not allow me to do so. I am required to pass in 2 hyphens followed by the alphabet that I specified here. Oops, it scrolled down a bit too much. As you can see, either the word or the alphabet, but either way I am stuck with 2 hyphens. So if I were to type help, it will show me the help menu, similar to the other 2 implementations I just went over. And the format is still the same. I just pass in the path to the file and then specify my 2106, 2016, and it will give me all of those results. It still supports multiple parameters, so if I say Virginia, it will give me all of the records associated to Virginia in the year 2016. If I were to say number of deaths is greater than or equal to 40,000, it still shows me the records in the year 2016. So the implementations perform in more or less the same way, but this is the one hiccup that I faced with C++, that I had to specify the flags using double hyphens as opposed to a single one. But nevertheless, it performs the same way. If I were to say again, age adjusted, death rate should be equal to 50. Okay, let's do 500. We get back a lesser amount of records, which proves that it is recursively searching and filtering out the results. So that was all on the CSV file parser. I hope you enjoyed the video. The links to the CSV file parser, or rather the GitHub link, will be in the video description. And thank you for your time.